All right, this topic, we are looking at infrastructure, anti-spoofing ACLs, and we're also going to be looking at uRPF. So first, with the infrastructure ACLs, basically what we are looking at are ways that we can configure access lists to drop any traffic that appears to be spoofed. So we only want to permit legitimate traffic, and there's two ways, of course, of implementing this: on ingress or on egress. Ingress, of course, we want to prevent any external networks. And we also want to be able to filter traffic or networks that are known to be invalid. So sometimes we can filter out just traditional RFC 1918 private addresses that should not be coming in from the outside. Now, we can also provision these egress just to ensure that there isn't any spoof traffic that's originating from our network, but also to allow any valid networks to be able to leave on egress. So here are some examples. We look at this edge router, and we have the IP access list extended. It's going to be called egress, and we're denying, let's say, traffic from the 10.1 subnet. We're denying traffic from the 127 subnet. And basically, all other traffic we want to go ahead and permit, and we want to log anything that's denied. Over here on the egress interface, we have traffic that should be allowed out, anything that matches the 10.1.1, and deny all other traffic. So sometimes we want to make sure that just legitimate traffic is allowed to be routed to the core. Now, when we look at uRPF, or Unicast reverse path forwarding, this is a way that we can prevent any spoof traffic, but also ensure that our routing protocols are secured, and making sure that we don't have any denial of service attacks that could infiltrate our environment. So anything that is found in our forwarding information base should be trusted, and we should not be relying on any untrusted routing. So we also want to make sure that we have some security in place, that we are ensuring that our dynamic routing protocols have authentication in them. Sometimes we can look at this as one of the first lines of defense against those attackers. There's two ways that we can implement this. We have strict and we have loose. So generally, the strict is going to verify traffic that's coming in through an expected interface. Make sure that our traffic is known, it's valid, and an alternative to egress and ingress anti-spoofing ACLs is this uRPF. All right, as far as loose, this is just going to be validating the existence of any source networks in our routing information base or in our route table. It also allows us to be able to provide just an additional method to be able to drop any traffics from any invalid networks. So here's a quick overview. We can ensure that the traffic is going to be arriving on a routed interface. We're going to be extracting that source IP, making sure that it's in our fib. If the location is found and it doesn't match the proper input interface, then the traffic is dropped. So it's like a double and a triple check. We're looking at the VIP list. Were you actually allowed in, or were you not allowed in? Loose, if the packet arrives on a routed interface, we are extracting the IP source address. We're using it to search our fib. And if the fib doesn't have the network, then the traffic is dropped. All right, so here are some examples of where we might implement this. We can see we have strict on one interface, that's allowing default route matching. It's allowing asymmetric routing. On our F01 interface, we're using loose, and we are logging packets that are going to be denied. And then of course we also have an example on the ASA. We can look at the configuration on what it might look like from the GUI in addition to where it might be placed. So outside interface, we should have this installed.